Hey everyone, so today we're going to be sketching a cubic function with help from the first and second derivative test. So the cubic function that we'll be sketching is f at x equals to x cubed minus 6x squared plus 9x plus 1. So the first thing that we're going to do is we're going to find the first derivative. And this is to help us find our x coordinates, which are our turning points. Then in turn we can find the y coordinates, and then we can plot those on the graph. So let's find the derivative. So we know f prime at x equals to 3x squared minus 12x plus 9, right? That's the derivative of that. So this is a quadratic now, so we can factor it. So let's do that. Let's factor the 3 out first to make it easier. X squared minus 4x plus 3. Okay, and then we can factor this, and it becomes 3. And then, so we need two numbers that multiply to positive 3 but add to negative 4. Okay, well that's x minus 3 and x minus 1, right? Two numbers that multiply to positive 3 add to negative 4. Perfect. So from this we know that x will equal 3 and 1. So now that we have this, we can sub those into the original function to get our y values. That'll tell us two coordinates. We already know one coordinate will be at 1 here, right? Because this is our y intercept. That's always the y intercept. So we already have 1. So now we're going to find some other y coordinates. So we're going to take these two and we're going to sub it into f at x. So let's do 3 first. F at 3 equals to 3 cubed minus 6 times 3 squared plus 9 times 3 plus 1. So this will equal to 27 minus 54 plus 27 plus 1, 28. So we add and subtract all these, and you should get 1. No calculator, that's 1. So now we know that one of our coordinates will be at 3 and 1. So let's put that on there right now so we don't forget. Bam. Right there is one coordinate, so now let's find the other one. And to find this one, we're going to sub in 1 for f at x now. So f at 1 equals to 1 cubed minus 6 times 1 squared plus 9 times 1 plus 1. And you'll multiply that all out. So obviously 1, 6, 9, 1, you get 5. So we know the other coordinate will be at 1 and 5. So let's put that up there. Perfect. So there's one more point now that we can find. It's the point of inflection. So to find that one, we're going to take the second derivative. So we have our first derivative. We're going to take the second derivative now to find the point of inflection. So let's do that. That's an x. Oops. Here, let me just fix that. There you go. That looks better. So second derivative, here we go. It becomes 6x minus 12. And from this we can tell that x will equal to 2, because that's how that equals 0. 2 there. So we know that x equals 2. So we'll sub in 2 for f at x. So let's do that. F at 2 equals to 2 cubed minus 6 times 2 squared plus 9 times 2 plus 1. And we'll know that this, that's a 2, that this equals to 3. So we know that the point of inflection will be at 2 and 3. So let's put that up there now, 2 and 3. And these are really the only points that we need to know what this graph will look like, because we know it's a cubic function. So let's start sketching it now. So we're going to come up like this, I'm going to hit that point. It's going to come down. So start turning and look a little something like that. Don't forget to have your arrows. So yeah, that's how you will sketch a cubic function using the first and second derivative test. I hope you found that helpful, and have a good day.